So let's now see the scientific methods. Also in our world, there are lots of problems in things like farming, our health, and the environment, and etc. And when we want to find solutions to these problems, we use a special way of thinking called the scientific method. And this helps scientists find the right answers to real-life challenges. In this lesson, we will learn about the scientific method, why it is important, and how we can use it to learn more about biology and science. Above all, let's now start with the concept of the scientific method. Imagine you are not feeling well and you want to go to the doctor. And the doctor asks you questions to understand what's wrong, examines you, and sometimes even sends you for tests. They do this because they want to be sure about your illness before giving you medicine. Just like doctors follow the steps to help you feel better, and scientists follow the steps to find answers to their questions and solve the problems. And these steps are called the scientific method. It's like recipe for doing science experiments that help us learning new things. Now let's see the main steps of the scientific method. When scientists use the scientific method, they follow this. The first one is problem identification. First, they figure out what question or problem they want to solve. It's like deciding what puzzle they want to solve. For instance, imagine you have the small trees in your backyard and you notice that some trees seem to grow taller and healthier than others. You wonder if watering the trees has something to do for its growth. So now the question is, does the watering the trees affect how tall and healthier it grows? Number 2, formulation of hypotheses. Next, they make an educated guess or a hypothesis about what they think might be the answer to their question. For instance, now you make a guess about what might happen. Your hypothesis could be, I think that if the watering the tree regularly, it will grow taller and healthier compared to the tree that does not get watered. Number 3, experimentation and observation. Then, they do experiments and carefully watch what happens. It's like trying different things and seeing how they fit. So that to design a suitable experiment, you must find out the factors that affect the problem you want to investigate. Just imagine you are doing a fun science experiment. You want to find out how something works, like making a plant grow taller. To do this, you need to pay attention to 3 special things called variables. Clearly, there are 3 types of variables. These are dependent variables, independent variables, and controlled variables. So, what is dependent variables? These are the factors in the experiment that change their values when the values of the other variables change. In simple terms, these are the things you're watching closely in your experiment. For our plant experiment, it is how tall the plant grows. So, if you give the plant more water, alright. and you look at how it affects the plant's height, development variables are like the results you are looking for. Also, independent variables. These are the factors which are manipulated so as to obtain different values for comparison. Or in a simple terms, these are the things you can change on purpose to see what happens. So, in our plant experiment, it could be how much water or light the plant gets. You change these things to see how they influence the plant's height. Independent variables are the changes you make. Controlled variables. These are the things you keep the same during the experiment. They do not change. In our plant experiment, this might be the type of soil you use or the pot the plant is in. The controlled variables stay constant to make sure your experiment is fair and that only the independent variable affects the dependent variable. They are like the constant that help you compare. So, in your plant experiment, you are looking at how tall the plant gets dependent. So, the conclusion on variables, changing things like water and light independent, and making sure everything else stays the same, control it. In order to understand how different factors affect the plant's growth, that's how scientists figure out how things work. For instance, to test your hypothesis, you decide to do an experiment. You choose two similar small trees, one that you will water regularly and one that you will not water at all. You keep everything the same. Example, the amount of sunlight and soil. Over the time you will observe how they grow. Number 4, data correction or recording. They write down all the information they gather during the experiments. It's like taking notes about what they have tried. For instance, you keep a diary where you write down what you do every day. You note the days when you water the first tree and when you don't water the second tree. You also measure the height of the both trees regularly and look at the levels to see if they look healthy or not. Number 5, data analysis and interpretation. After that, they look at all the information they have collected and try to make a sense of it. For instance, after a few weeks or months, you look at your diary and measurements. You note that the tree you watered regularly has grown taller and its leaves looks green and healthy. The tree you didn't water, on the other hand, is shorter and its leaves look dry and wintered. Number 6, drawing a conclusion. Once they understand everything, they decide if their hypothesis was right or wrong. For instance, based on what you have observed, you can conclude that watering the trees regularly does make it grow taller and healthier. Our hypothesis turned out to be correct. Lastly but not least, reporting results. Final, they share their findings with others so that everyone can learn from their discoveries. So, you used the scientific method to find out what watering the tree can affect how it grows. Therefore, we can conclude that scientific method is like a special way scientists use to solve problems and learn new things. Note that If your results do not support the hypothesis, do not leave out the experimental results. Give the possible reason for the difference between your hypothesis and experiment results. Give idea of further investigations to find answers to the problem. So, the importance of the scientific method is essential for many reasons, especially when it comes to find the reliable answers to the problems. The first importance is reducing bias. It helps to make sure that our personal opinion and what we believe because of our culture do not get in the way of finding the truth. Number 2, relying on experiments. Instead of just guessing or saying what we think is right, the scientific method relies on doing experiments. Number 3, get confident results. When we use the scientific method, we get results that we can trust. It is like doing mathematics problem and getting the same answers every time. Number 4, proving and repeating. The scientific method also lets us prove things and do the same test again and again to be sure. Now let's see the applications of the scientific method. Number 1, carrying out experiments. Think of experiments like science tests. Scientists use the scientific method to figure out how things work. Number 2, project work. Imagine a big school project. It is like a fun mission to learn a lot about something. Number 3, field study. Sometimes scientists like to step outside of their laboratories and go explore their real world. This is called a field study.